Good morning and welcome to PWN Physics 365. Physics every single day of the year. Physics past, present, and future. The podcast doors are closing.
Well, alright. Hello, friends, and welcome back to PWN Physics 365. Physics in your face every single day of the year. I am your host, Eli Hibbett, and welcome. We are in the physics zone. So let's take a look. On this day in physics, 30th of January, 1991, we said goodbye to John Bardeen, an American physicist and electrical engineer. John, so far, is the only person to have won the Nobel Prize twice. The first time he won was in 1956 with two others for the invention of the transistor. You know, that little thing called the transistor. As if this wasn't enough, the next time he won again with colleagues in 1972, a mere 16 years later, for the development of BCS theory, which is a theory which describes superconductivity and breaks it down into a property which exists at the microscopic scale. So, for that, sir, PWN Physics 365 salutes you. You had a wonderful time, a wonderful life. He had a long run, too. He was like, in his 80s. All right, so anyways, that's what happened on this day in physics in 1991. And what happened on this day in physics today? We have the word of the day, momentum. It would be hard to do a word of the day about mass and inertia and not follow it up with momentum. As if mass and inertia weren't hard enough to describe, I think momentum is even harder. This is what momentum is. It is the product of velocity and mass of an object. If you are stationary, your momentum is zero. The faster you're going, the more momentum you gain. There is also something called conservation of momentum, which means that the total momentum of a system must be conserved. This is very important for collisions. If two bodies collide, the total momentum of the system will be conserved, which means that one body could leave the collision with a much higher velocity than it entered. This is especially the case when a small object moving slowly collides with a massive object moving quickly. So that is a very brief touch on what momentum is. And so you sort of see how these words are getting intertwined. Mass, inertia, and momentum are, very closely related quantities. Momentum is related to velocity and, of course, mass. Mass is related to inertia, and you need to have a certain amount of momentum to overcome inertia. So there you go. That's our word of the day. Momentum. I can't say it. It's a tough word. But all right, let's take a look at our third segment here, the killer resource, conservation of momentum. Newton's Cradle explained. So if you don't know what Newton's Cradle is, it's this kind of fancy piece of officeware that some people have. It's the 5 steel balls. They're like pendulums, and you pull one from the side and you let them smack back and forth, and the one hits all 4, and then the one on the farthest side comes up and goes back and forth, and it looks awesome. And it is a demonstration of our word of the day, conservation of momentum. And so I found this really cool YouTube video where this you can't see his face. I don't want to say kid, but he seems like younger, less than 30. Maybe I'm wrong. If I am, I'm sorry. But he does a really, really, really good job of explaining the physics behind Newton's Cradle and how momentum is involved in that, and how the momentum transfers through all of the balls in the middle to send the next one flying off into space. So if you are interested, head on over to the blog, pwnphysics.blogspot.com, for a really cool video and some more information, episodes past, and other great resources. So I think that's going to do it. It's going to wrap it up for today, and so I will catch you again tomorrow with another episode of PWN Physics 365. Physics every day of the year. I'll see you tomorrow, guys. Take care.
The pod bay doors are reopening. You may now resume normal life functions.